All right, so multiplying polynomials. We've already covered our exponent rules, right? When you multiply, you have exponents and you multiply like bases, what do you do with the exponents? Add them. And if it's power to a power, what do you do with the exponents? Multiply them, right? So let's look at some of these examples. We're going to multiply some monomials, right? What's a monomial? What kind of polynomial is a monomial? One term, right? What's two? Binomial, right? Okay, so here we go. 5x to the third times 2x squared. Well, let's start with what's 5 times 2? 10. X. What do we do with those exponents? X to the what? Fifth. Okay? I don't like what they did with part B. Does anybody see what will drive me nuts there? Not that they're multiplying in that right, but the operators are right next to each other. That's Bush League. Come on. That makes you look like you're not very good at this stuff. So anyway, let's multiply these. Negative times a negative. All right. So positive what? 24. X times x. X to the first times x to the first, right? X squared. Okay? All right. How about part C? See, now we got some fractions and we got some x's and y's, right? Well, let's start with the fractions. What's 1/2 times 3/4? Okay, well, it's 1 time. You guys know when you multiply fractions, you multiply it across the top and then across the bottom, right? So 1 times 3 is 3 over what? 8. Okay? X to the what? X squared times x to the 9th. X to the 11th. Y to the 6th. Okay? All right, so just, huh? It is, yeah. All right, let's move on to exercise 2. So I want to find each of the following products in simplest form, right? In other words, when they say simplest form, in this case, means all like terms combined, if there are any, right? So let's in standard form, decreasing order of exponents. You guys, you've heard of, you know how to distribute, right? Okay. Equals, and I'm not going to draw these all the time because it's also kind of babyish, but just for now, right? We're going to distribute that 2x through there. What is 2x times 3x? It is not 6x. Huh? 2x times 3x. It's not 6x. X times x, guys. 6x squared.
Oh.
Right? And then 2x times negative 1. Minus 2x. Okay? You get the idea? Why don't you guys do the next one on your own? Make sure you have an equal sign. Distribute the x squared. Use your properties of exponents. What should we get there? Anytime now. I'll be right here. What's the result of multiplying through there? 4x to the 4th plus 3x squared. There you go. Okay? Use your properties of exponents. And do the same thing with part C. You might want to put your equal sign down here. There's not a lot of room to the right. Well, what do we get for C? Go ahead, say it. Negative 4x to the what? I can't hear you. X to the third, yep. Y to the fourth. Huh? What? Then keep going. That's what? Plus, minus what? Because a negative times a negative is a positive, so plus 10x to the third. Right? It's not really different than like, when we were doing it up here. It's just now getting distributed, but it's still just multiplying. Okay? Now how about these two binomials multiplying them? Anybody know what to do here? No? Do we still just distribute? Except, like, how many times are we going to distribute now? No. Huh? Did you say twice? You were correct when you said twice. So, instead of having like a single monomial out here, I've got two things. So I'm going to distribute through the x, and then I'm going to distribute the 2. That's all. I'm just going to distribute twice. So go ahead and distribute that x. X times x is what? X squared. X times negative 6. Negative 6x. Okay, now distribute the 2. 2 times x. Plus 2x minus 12. Okay? Is there anything we can do here now to clean it up? We can combine like terms. So what's that give us? Right? The negative 6x plus 2x, right? Okay? You get the idea, guys? You just distribute twice and then combine like terms. So in this one, you'll distribute the 2x, and then what will you do? Distribute the 7, okay? Maybe go down below. It's kind of a tight squeeze there. So everyone go ahead and do that now. Distribute through twice with each of those terms, and then combine like terms. Or that. 2x squared, right? Plus what? 6x. And now you distribute the 7, and you get what? 7x plus 21, right? Now I have like terms to combine. So it gives me 2x squared plus 13x plus 21. Okay? Try, but just real quick before you start the next one, just for later on, I want to draw your attention to something. In this one in part D, you see this negative 12? Tell me where did this negative 12 at the end come from over here? Negative 6, right? Okay. Where did this negative 4 come from? But like from in here. But from in here. I'm not worried about the x right now. Just the negative 4 part. From in here, where would that come from? The 2 and... So 2 minus 6 is what? Negative 4. And 2 times negative 6 is negative 12, right? Just keep that in the back of your mind for later on, because like when we go backwards, you want to be thinking about that. Okay, so go ahead and do part F then, right? Distribute the 3x, and then distribute the what? No, the negative 2, thank you. All right, do that now. All right, what did we get for F? 15x squared minus 13x plus 2. Show of hands. Yeah, okay. Well, when we distribute the 3x, what do we get? 3x times 5x is what, everybody? 15x squared. Keep going. Minus 3x. And now we're doing the negative 2. So negative 10x plus 2. Negative times a negative, right? Now we combine the like terms in the middle. 15x squared minus 13x plus 2. Okay? If anybody got lost in there, raise your hand. Yeah, okay, so where? What part did you get confused on? Hmm? Well, look up here. Did you understand these up here? We just distributed this through one? Okay, we're doing the same thing, just twice now. Now, instead of having one thing out in front, you got two things, right? So you distribute the first one through, just like you did up top, right? And then you distribute the second number through, just like you did up top. And then you're going to have some like terms to combine with this one then. That's it. At the end, okay? All right. Let's go down here. Now we have two binomials here. Product of two binomials, x minus 1 times x minus 3, okay? So they want us to find it. And by the way, when we multiply these two binomials, what do we get each time here? Three-term polynomial, what do you call it? Trinomial, okay. You won't always, right? But most of the time you will. All right, so let's multiply our x minus 1 times x minus 3. Okay? Hey, yeah, help us out with that, will you? Distribute this x, tell us what we get. X times x. Squared. There. Keep going. Don't write it down. Just tell me and I'll write it down. X times negative 3. Negative 3x. Now distribute what? Go ahead. So what? Yeah, or we can just say negative. We'll leave it one there, right? Multiplying. Multiplying, not adding. Negative times a negative. Positive 3. All right? And now we're going to do what? And we get what? What do we get? This whole thing becomes negative 4x? Okay. Plus 3. So you notice I'm using equal signs here, right? As you should too, right? Better be, because that's what I've been teaching you. And what does that mean about this trinomial and these two binomials? There's an equal sign in between. What does it mean? They're equal, right? This one? Negative 3x minus another x gives you negative 4x. So, right? It went in here with the 4, negative 4. So if these two things are equal, wouldn't that mean that any value I put in for x in this one, if I put it in here, wouldn't the outcome be the same? Okay, so that's what they want you to do in this table here, and you can use your calculator to do that, right? So the trinomial is going to be our x squared minus 4x plus 3. And we're going to plug in, well, we're going to let the calculator do the table of that. I mean, we can plug it in. We can plug it in. Yeah, we've done stuff like this, right? So let's put both of these in to our graph. We're not worried about the graph, right? We just want a table of values, yeah? Well, follow along with me. You can just use Scratchpad for this. Go to that one. So now put that first, the two binomials, and what was it, x minus 1, minus 1, get out of there, and another parenthesis, x minus 3, right? Okay? And now go down and put the other one in. It's x squared, right? X squared minus 4x plus 3. Okay? Oh, by the way, did you notice the graph, the second one, laid right on top of the first one? Does that tell you something? That they must be equivalent, right? You know how to do a table of values on this? Okay. Well, I'm going to show you. Everybody watching?
No.
Well, then commence watching. You know how? Okay. And you? What do you think? Table. And the only option here is split screen table, which can get into, I can show you how to. Okay. So there's all our inputs, right? I like to make this table a full screen. Everybody pay attention here so I can see, I want to see both columns here, or all three columns. So watch what I do. Pay attention, everybody look up here. So I want to do it again. Looking up here. So you see your touchpad button up here, you see this little thing that looks like maybe a symbol for page sorting. Okay? So if I hit Control up arrow, well, mine's goofing. I don't know why I have this. Yeah, I don't know, mine's Control up arrow. Okay, it doesn't want to do it.
I don't understand.
It could be a separate document.
Mine went upside down.
What's upside down?
My x minus 1 x minus 3.
What exactly is upside down?
The thing that is like this.
The graph?
Yeah,
It looks like this, yeah?
but upside down.
So it goes like this, then you type something in wrong.
I don't know what I said wrong.
We'll go back and look at it. Hit your tab button and look up at it.
I did, I redid it.
So I typed something in wrong. So anyway, they want us to do a table from 0 to 4, right? So we can bring that right up here. So these are our x's, right? If you go over to the right a little bit, you see how we have our two functions in here now? We will. No, it didn't do it either. This is acting up. Okay. Well, there it is. Anyway, we'll have to work that glitch out later. Did anybody get the two columns of the two entries in there? Or just the one? It's weird. Is it? I wonder if that's a software update that went glitchy. But anyway, we'll fill them in here. So it's 3, 0, 0, -1, 0, 3. And the other one gets the same values. Okay? No? Anybody see that on their table? I don't know if anyone was able to get the extra third column. So you got the other column on yours? Okay, I don't know why mine wasn't doing that. That's strange. Yours what? Okay, all right, something I'll have to work out. That's never quite done that before. All right. Well, anyway, we can worry about the calculator later. The point of this is that we took this thing, distributed combined like terms, got a whole different looking expression, right? But they are equivalent. And by the way, let me ask you a question again to think about for later. Look at these two binomials. In this trinomial that resulted, where did that positive 3 come from? Everybody. -1 times -3. And in the middle, where did this -4 come from? -1 minus 3. So adding them gave you the middle term. Multiplying them gave you the third term. Okay? Just keep that in mind. All right, let's go over to the next page. Okay. Go on with distributed property. What's it, the calculator?
Oh.
Okay, good. You'll catch up. And you'll catch up. You were in the nurse. All right, so here's what we're going to do. And here, now listen. Something here that more than half of you, maybe all of you, are going to do this, even though I show you it's wrong. But for some reason, as I live and breathe, I know that you will do it, even though I tell you that's incorrect and wildly in error. See this 2x plus 5 squared? What does that mean I need to do here?
You gotta do 2x plus 5. I don't know.
So should I square the 2x and then just square the 5? No, oh, no, you don't. That does not work that way. Okay? So somebody was saying, what does it mean to square something?
2x plus 5.
Right, it's this whole thing times itself. 2x plus 5 times 2x plus 5, right? And from the previous page, we know what to do now, don't we? Okay, so let's do that. Let's distribute the 2x and then distribute the what? 5. What do we get when we distribute the 2x, everybody? Plus what? 10x plus 10x again plus 25. I mean, just real quick. Hold on, hang on. Do you notice that? Well, I'll do it with a simpler one later. But yeah, so let's combine like terms. 4x squared, go ahead. Plus 20x plus 25. Now, a lot of kids would look at this for some reason and say, okay, this is 4x squared plus 25, and they're done for the day. That is so wrong, okay? You don't just square those two things in there when there's addition and subtraction. Everybody got that? It means to write out, multiply it by itself, distribute twice, combine like terms, okay? All right, this one looks a little messier. What are we going to do here? Anything different? Just more of the same, right? It'll be a little bit longer, won't it? We're still going to distribute twice, but now we're going to distribute the x to there, to that term, and that one, right? And then what? Then distribute the 2 through there, right? So let's distribute that x. X times x squared, everyone.
I have no idea. X.
You have no idea what x times x squared is?
X cubed?
Yeah, you did have an idea. You're always lying to me. X cubed
I didn't know that's what that was.
Keep going.
4x squared.
plus 4x squared plus 3x. Now what are we going to distribute?
2.
Go ahead.
2x squared.
2x squared
Plus 8x.
plus 8x plus 6. So same thing, just now it's a little less messier, right? And now we have some like terms to combine, don't we?
Yeah.
So let's start with our highest one, x cubed
Plus, there's 6x squared.
plus 6x squared. Keep going.
11x
Yep,
plus 6.
plus 6. You with me? It's all the same, right? Distribute, combine like terms. Distribute, combine like terms. Okay? All right. What about this one?
You gotta do it to every.
So, yeah, we can only do 2 of these at a time. Okay? Now, I like to do it this way. I like to just take this first one and just let it sit here for now. Okay? With me? And now, other set of parentheses, okay? Watch, this is how I do it. I'm going to take this. We know how to do this, right? Okay? But I still need the x minus 4 sitting out here. Later we'll deal with that, right? So let's distribute these two binomials, multiply these two binomials. What do we get? X squared. What? Minus 5x.
And then 3x.
Plus, don't say and then.
Plus 3x.
Yep. Minus 15. Anything we can combine in there? So let's keep the x minus 4 here for now.
Negative 2x.
So x squared minus 2x minus 15, right? It's the same thing we did on the other page. And I distributed twice. I combined like terms. The only thing different is I'm holding that x minus 4 up there for now. Now I'm going to do the x minus 4. Now, just like this one. Okay. So distribute this first x through here. What do we get?
X cubed.
X cubed minus 2x squared minus 15x. Now what's going to get distributed? The negative 4. Go ahead. X, negative 4x squared,
Negative 2x,
Mm.
negative 8, or 8x, plus 8x,
positive, negative times plus 8x,
and then, minus 45, right? No, 60,
sine
plus 60.
plus 60. There we go.
That was like, that's math in my head, because I know there's the 15-minute quarters in an hour.
There you go, right?
That's what I was thinking.
2 of them are 30, so 4 of them have to be 60. So let's clean it up. X cubed. So we got that and that. What do we got?
Oh, negative 6x squared,
Mm-hmm. Now that guy and that guy.
um,
Minus 7x
plus 60.
plus 60. There you go. Got it?
When it
Okay.
comes to like 8 and adding this like 12, 15, 7,
You got that.
I can't do my 8s staples, I don't really remember my 9s. My 6s.
All right. So, part D. Does that mean I'm just going to cube the 3x and then cube the 2?
No.
Good. That means I'm going to do what? So this will be what? 3x plus 2 times plus 2, right? And I'll just keep this first 3, I'm going to move to the left here a little bit. I'm going to keep the first 3x plus 2 here, right? And then take care of these two guys. And now it's just like over here. Everybody got me?
Yes.
So what I want you all to do is go through this, distribute, combine like terms, and then distribute this binomial through that when you get done. Okay? See how we do.
What would like 2 times an exponent be?
2 times the next one.
Yeah, like 9x squared times 2.
18x squared.
What?
18x squared,
Oh.
right? Here's what you should have. How do we do?
I got it right.
Okay? Probably did all that.
You got it right. Oh, I said
Yeah,
you
yeah.
got it wrong. No.
Yeah.
Oh.
Now, you don't have, like, some people like to do the first two to begin with and then have the third binomial over on the right waiting for it. I don't, because then you got to think about distributing to the left. It doesn't matter. I just like to distribute the thing on the right. Does that make sense what I'm saying? Like, I could have multiplied these two first and just kept this one all the way down until, but I just find it's more comfortable to do it this way, okay? All right. Any questions on that one? We got stuck somewhere? All right. It's just a matter of knowing what to do with your exponents when you multiply like bases, right? Knowing your times tables and knowing how to combine like terms. All right?
Ooh, I'm gonna have to pass.
All right, let's try this guy here. I don't know, that actually, hang on. You know, think. And you know what? Let's just skip the part B. Let's just practice one more time doing the A. Just let's multiply this. So we'll do 3x plus 2. Everybody another shot to make sure. Plus 1, okay? So multiply that out, distribute twice, combine like terms, okay? And, you know, also, here's a note, I'm going to just say, skip number 6 and 7 in homework. All right. Just as I think about it, it starts to annoy me. And I just wrote that right where I'm going to need to expand this thing, didn't I? I think I can move it. Yeah, look at that.
Oh, finally using those things to your advantage.
Yeah, finally worked out.
You know, it's always like, I was like, right, and then the whole screen
All right.
moves. What?
All right, so let me get this up and see.
Wait, it says trinomial, but I got 4.
4. You better combine like terms then.
I did.
Well, then you can't have 4. So you should have gotten, let's see, 6x squared, right? Plus 3x plus 4x plus 2.
Oh.
And then that's
You were doing up here.
plus 7x plus 2. Did we get 6x squared plus 7x plus 2, guys? Okay.
Yeah, that is supposed to be your answer. Right there.
All right. Let's look at some Regis questions. A couple of them should not be in this section. So on this one here, we're going to hold this for 7.6.
That's far ahead.
So don't go scribbling it out. Okay? Because we'll come back to it in 7.6. And let's move on to number 2. So this is just like what we were doing, except one little tweak at the end. You just need to know how to add or subtract fractions. Guys, when you add and subtract fractions, what do you need? Common denominator. You don't need it when you're multiplying, right? You multiply, just multiply across top and the bottom. Add and subtracting, just need a common denominator, okay? So this one's going to work out. This will just tag along for the ride, right? You're going to do this, aren't you? Okay, so everyone gets started doing that. Make sure that minus 1/4 x squared stays along for the ride because it's part of it, okay? So let's see, we should be getting, let's see, 3x squared plus 21x minus 4x minus 28, then just minus 1/4 x squared, right? Leave it there for now. We good with that part so far, everyone? Sign mistake or something? Sign mistake maybe, or? You've got to be tight with those. So we get 3x squared plus.
The other ones, I keep doing the stuff that I did for like the last problem set, so like keeping it. I don't know, I keep doing like that. It's different. I don't know. Last problem set.
Oh, 7.1. What we're just doing there, 7.1 was, really, 7.1 was just like combining like terms part of this in standard form, right? So what's that? Plus 17x minus 28 minus 1/4 x squared. Anybody get a final answer? You can't take that 3x squared and subtract 1/4 x squared. Okay. Well, that's 3 over 1, right? We need it to be over what? Over 4, don't we? Right? Okay. What do they do to that 1 to make it a 4? Multiplied by, so I have to do the same to the 3. 12. That's not hard, is it? And now, what's 12/4 minus 1/4? A what? 11 what? Fourths. 12 minus 1 is 11. X squared. 17x minus 28. Okay? The only thing different with this one is you had that, when you went to combine like terms, you had that negative 1/4 x squared. So you needed a common denominator. You understand I get a common denominator, right? Whatever you do to make this denominator a 4, you do the same to the numerator. You know, multiply them both by, and then you can combine them. Okay? All right. Number 3. X, negative 5, 2x plus 3. Polynomial in standard form. Which statement is true? Oh, by the way, the constant term, you know, that's the whatever is like without the variable. Like this will be the constant, negative 28. You guys know that, right? Or if you didn't, you do now, right? Okay. So what are you going to have to do with this, guys? Multiply it out, yeah. Distribute, right? I don't need the x in parentheses, so just do it. X times minus 5 times 2x plus 3. Does it matter which 2 you multiply to begin with? Does it ever matter what order you multiply things in? It doesn't. So everyone multiply through whatever way they want to do it. Okay? And then see if you can answer. So the only way to answer these is to actually get a nice trinomial standard form, okay? Wait now, distribute. If you want, you can start distributing the x through. The 2x plus 3 will just go along for the ride, right? Get you started. Do that. Do this right here, see? I'll need to keep these. Right? Hang on. I think you guys take it from there. So you got x squared times 2x is 2x to the third, right? Because that's x to the first, right? Add the exponents. Plus x squared times 3 is 3x squared, right? Now do the negative 5. Minus 10, x times x is x squared, minus 15x, negative 5x times 3. Now, Hannah, what are the like terms we can combine in here now? Which terms had the same base with the same exponents? 3 and negative 10. So the x squared terms combine, right? So what we got? So 2x to the third, 3x squared minus 10x squared gives you how many of them? It's 3 minus 10. Anybody?
7.
No, it's not 7. 3 minus 10 is not 7. What is it?
Negative 7.
Negative 7x squared minus 15x. Right? All right, answer the question. Which one of those is correct? Number 1, the constant term is 2. Is there even a constant term in there? There isn't one, right? They all have x's on it. What about choice 3? What's the degree of that expression? What's the degree here from yesterday? 3, the highest exponent. So the leading coefficient is 2. Is that true? Because it's a 2, this coefficient on the thing with the, what about the number of terms is 2? Obviously not, right? So choice 2. Okay? All right. Let's cross this one out for now. And the number 5, that's got to go with 7.5. So I'll hold for 7.5. Boy, next semester's kids are going to have to solve. All the editing will be dialed in. All right, let's move on to number 6. About volume of the box. And we talked about it earlier. How do you find the volume of a box or a rectangular prism? Length times width times height. Okay? So there you go. Bring that over. So volume is length times width times height. Did they give you the length and width and height in this problem? They did. About with numbers, right? With expressions. So what are you going to do with those 3 expressions up there? Multiply. And so just like we've been doing in the lesson, isn't it? Yeah. So your volume, and then they just want to know the coefficient of the second term, right? And make sure, so volume is going to be 2x times 3x. Well, that's a 3x plus 1. Got to group it. Times 5x minus 6. Boy, it sure does seem a little bit like the last one we did, doesn't it? Maybe start by, doesn't matter which one, I'll do that one first, right? And then this one will come along for the ride a little bit. So everyone do that now. It's going to work a lot like the last one we just did. Let's see if we can nail it this time. We at least get that step. Did you distribute through the 2x? Yeah, all right, so normally when you distribute, I said the parentheses go away, but like, since we have another time, we have to distribute again, so we gotta keep them until we do that. So like when you get finished distributing, I guess, it'll totally go away. That makes sense? Okay. And then you're just gonna distribute twice, right? And then the last thing you'll do is what? Distribute. Mm-hmm. I've only said it 28 times. Distribute. Combine. Are you all kidding? Holy smokes. Yes. Distribute. Combine like terms. Distribute. Whew. Ah. Great googly woogly.
Do you have a question why you came to do
Right now, you mean?
that? Are you?
Maybe.
Why did you?
Who's asking? Well, because I hate children. Of course. I want to see them suffer. Hmm? Yeah. I'm careful. Ah, they're okay. Anybody have a final answer here? Just, I don't, not for the term, but what's the final product? What? Go ahead, we got 30x
Squared.
cubed, x squared times x to the first. Add the exponents. That's x to the third, right? Go ahead. Negative, well, so 6x squared times 5x, 6 times 5 is 30. X squared times x is x to the third. But, oh, I was asking for the final, but anyway, okay, so 6x squared times negative, so negative, that, okay, now it's a negative. I thought you were giving me the final answer, I'm sorry. So negative 36x squared, right? We did that. And now we're going to do this one. So what do we get with the 2x distributing? Plus 10x squared minus 12x. And what terms can we combine in here? Which terms? The negative 30x squared and, so volume equals 30x to the third, what? Minus 26x squared minus 12x. So there's that, okay? So let's answer the question now. What was the question actually asking? What is the coefficient of the second term? This guy right here, negative 26. Okay? I think I saw some light shining in somebody's eyes out there. Maybe not. I don't know. We'll see.